So now we will be discussing about the second part of the endogenic processes. And again, the big idea is that endogenic processes are internal processes that occur within Earth, and these result in the reshaping of the Earth's landforms. So again, here are different learning competencies or learning targets that hopefully at the end of this chapter, you guys will be able to achieve. Okay, so first we have volcanism. Now, volcanism is one of the endogenic processes. It is a phenomenon in which molten rocks or magma are erupted from the Earth's interior onto the surface. Now, volcanism takes place at or near divergent and convergent plate boundaries. A volcano is a vent or a series of vents on Earth's crust. The vent is like a chimney. It is where magma, ash, and gases are released. The mouth of the vent is referred to as the crater. The large, almost circular depression formed either by the collapse or explosion of the volcano is the caldera. Crater lakes sometimes form in these calderas. So, volcanic activity is used to describe the type of classification of a volcano after it has erupted. Volcanoes may be classified as active, dormant, or extinct. So first, active volcanoes are, as described by the Philippine Institute of Volcanology and Seismology, or PHIVOLCS, are volcanoes that have erupted within historical time in the last 600 years or having erupted within the last 10,000 years. Example of active volcanoes in the Philippines include Mount Mayon in Albay, Mount Taal in Batangas, Mount Canlaon in Negros Occidental, Mount Bulusan in Sorsogon, and Mount Ragang in Cotabato. Dormant volcanoes are volcanoes that or which have not erupted for more than 1,000 years but have the potential to be active again. Examples of dormant volcanoes in the Philippines are Mount Arayat in Pampanga, Mount Apo in Mindanao, Mount Isarog in Bicol, and Mount Makiling in Laguna. Extinct volcanoes are volcanoes that have not erupted within the last 10,000 years and are unlikely to erupt again. Examples of extinct volcano in the Philippines are Mount Batulao in Batangas, Mount Cuyapo in Nueva Ecija, and Mount Landong in Pangasinan. Okay, so as two tectonic plates collide, the slabs of rocks descend into the mantle. The heat generated by this mechanism facilitates the formation of magma. Magma production at the subduction zone occurs due to the following conditions. So first, increased temperature due to friction. We have to take note that friction heats rocks as one plate moves under another. The additional heat contributes to melting. Second, addition of water to the asthenosphere. A subducting plate is covered by oceanic crust which is soaked in seawater. As the soaked oceanic crust dives into the mantle, the water boils to generate steam. The temperature increases with depth. Steam rises, adding water to the hot asthenosphere directly above the subducting plate. The addition of hot water melts portions of the asthenosphere, forming large quantities of magma. And then finally, we have pressure relief melting or decompression melting. Melting due to pressure relief happens when rocks in the asthenosphere flow upward when a subconducting plate descends. Magma generated at the subduction zone is andesitic. It is richer in silica than basalt and is viscous, and trapped gases cannot escape easily. Because of this, the eruption is explosive and produces ash. So next we have divergent volcanism. Magma production at the divergent plate is facilitated by pressure relief melting. It is associated with spreading, which occurs when the hot asthenosphere oozes up to fill the gap. At the ocean ridges, the lava solidifies into pillow lava. The formation of this pillow lava is often preceded by non-explosive eruption. The magma generated as the two plates diverge is basaltic. Next, we have hotspots. So the third environment in which magma forms but is not related to plate boundaries is called hotspots or mantle plumes. These are columns of rising mantle materials that begin to melt as they rise to lower pressure and shallower depths. If the lithosphere is weak, the magma breaks through to form a volcano. If a mantle plume rises beneath the sea, eruption builds submarine volcanoes and volcanic islands. An example of a volcanic island is the Hawaiian Islands. So, the composition of magma determines the explosivity of a volcano. When a volcano erupts, all three states of matter, solid, liquid, and gas, are ejected. So first off, we have gases. Volcanic eruption emits a variety of gases. In addition to water vapor and carbon dioxide, toxic gases such as carbon monoxide, sulfur dioxide, hydrogen sulfide, hydrochloric acid, hydrofluoric acid are emitted. Gases sometimes reach the lava on the walls of rocks to form brightly colored sublimates. Lava refers to magma that flows out of the Earth's surface. Its temperature may be from 500 degrees Celsius to over 1,400 degrees Celsius. Because of its high temperature, combustible materials such as houses, trees, and gases burn when engulfed by lava. As the lava cools, it darkens in color and forms frothy crust. Lava consists of mixture of oxides, generally silicon dioxide. Depending on the percentage of silicon dioxide, lava may be classified into felsic or silicic, intermediate or andesitic, and basaltic or mafic. Now, viscosity, which is resistance to flow, is affected by the composition of the lava. Felsic lava is more viscous. It solidifies within the crust before reaching the surface. It results in explosive eruptions. On the other hand, basaltic lava is less viscous and flows easily. Because of its fluidity, it rises rapidly to erupt at the surface of Earth. The intermediate type of lava, known as andesitic lava, has a varying type of eruption. Next, we have pyroclastic. So the solid particles thrown out in volcanic eruption are known as pyroclasts or tephra. So, depending on their sizes and shapes, they are categorized into volcanic blocks, lapilli, volcanic ash, or volcanic dust. Ash clouds may cause rains that bring about mud flow called lahar. Mud flows behave like wet concrete. They move downhill and bury everything in their path. Flooding due to lahar was the major source of damage in the province of Pampanga when Mount Pinatubo erupted. Now we move on to earthquakes. Now, have you ever experienced like seeing hanging objects swing back and forth, dishes rattle, or the whole house shake? What you felt and saw was probably due to an earthquake. So, an earthquake is a sudden motion of earth, and in the Philippines, a number of strong earthquakes have been recorded. And as you can recall, like the past couple of months, like last year, we have been hit by a lot of earthquakes, and particularly, if I'm not mistaken, like it was December 25, Christmas Day. Like this is the latest volcanic or earthquake which happened in Batangas, if I'm not mistaken. Now, earthquakes can also be classified based on their location. So we have shallow focus earthquakes occur along ocean ridge system and transform boundaries. They are long but close to the surface, and they may be 720 kilometers long but only 40 kilometers deep. Majority of the earthquakes are actually shallow focus earthquakes. Next, we have medium focus earthquakes. So these occur along transform and divergent boundaries, and they are of moderate length and have depths of about 480 kilometers. Now, the most destructive earthquakes are the deep focus earthquakes, and they occur along subduction zones. Oceanic trenches are associated with this type of earthquake, and they are short in length but occur very deep. So, earthquakes may be classified based on their depth, origin, and volcanic activity. So, first, if the tremors are due to a sudden displacement of the Earth's crust along a fault, they are referred to as tectonic earthquakes. Most earthquakes, take note, in the Philippines are of tectonic type. Next, origin. If the earthquakes occur deep within the subduction zone of colliding plates, they are referred to as plutonic earthquakes. And then finally, volcanic activity. Earthquakes associated with volcanic activities are called volcanic earthquakes. The 1911 earthquake felt in Manila and southern Luzon is volcanic in type. These were due to the eruption of the Taal volcano. So, the origin or the point of origin of the earthquake below the Earth's surface is called the focus or the hypocenter. And the point on the Earth's surface directly below the focus is called the epicenter. When the rock moves, the waves are radiated outward in concentric spheres. Next, intensity. So the instrument used in detecting and measuring earthquakes is called seismograph or seismometer. There are different types of seismographs. One type measures the vertical or up and down movements of the ground. Others measure the horizontal or side-to-side movements. The record made by a seismograph is called a seismogram. One way to determine the strength of an earthquake is to evaluate if it affects on a particular place. It is described in terms of intensity, which is expressed in Roman numerals. Examples are the modified Rossi-Forel intensity scale, which was adopted by the Philippines as PAIS, or FIVOX earthquake intensity scale, and the Mercalli scale used by the USGS, or the United States Geologic Survey. Another way of describing the strength of an earthquake is by its magnitude. The magnitude of an earthquake is a measure of the energy released by an earthquake at its source. The Richter scale, developed in 1935 by American seismologist Charles Richter, is the universally used scale for gauging earthquake magnitude. It ranks the magnitude using Arabic whole numbers, and it measures the magnitude of an earthquake based on the height of the largest wave recorded on the seismograph. Okay, so next we move on to earthquake waves. So we have two types. We have body waves, and we also have surface waves. So for body waves are waves that travel through the interior of a body, such that of Earth's inner layers. There are two types of body waves that are distinguished by their effect on their medium as they propagate. So the P waves, or the primary waves, are compressional waves that create compressions and rarefactions in the medium in which they travel. The motion of the particles of the medium is in the same direction in which the P wave is traveling. P waves pass through fluids and travel fast at speeds between 1.5 kilometers per second and 8.8 kilometers per second. Okay, so the secondary waves, also called as S waves, are shear waves that move perpendicular or transverse to the direction of their propagation. So as you can see in the picture, that's how S waves move. And you also have to remember that S waves can also pass through solids, or that can only pass through solids. They travel more slowly, usually at 60% to 70% of the speed of the P waves. So next we have surface waves. Now, surface waves, in comparison to the body waves, only move along surface. There are two types of surface waves that are distinguished based on how they affect the material on which they move. Love waves cause horizontal motion, resulting to a side-to-side motion. Rayleigh waves cause vertical motion, resulting in an up and down motion of the ground. Surface waves causes more property damage because they produce more ground movement and travel more slowly.